Hello, Mike Akko Kumui here. Thanks for the time and attention, guys. This is the last part of your Unit 6 review, linear equations and graphs. We're going to primarily be talking about absolute value graphs. Okay, so we're going to start with a joke. Why should you take a pencil to bed? Pencil to bed? To draw the curtains. Yes, to draw the curtains. All right, ha ha ha. All right, let's get the math. Let's get to work here. All right. The Desmos is going to come in really handy here, and I encourage you to do this exploration yourself. Okay, I'm gonna graph something like that. Now, there's a couple ways we can do this, but absolute value. Let's recall some things about absolute value. No matter what the input is in absolute value, the output will always be positive. Someone described this to me as like a fun house. Okay, a fun house. If you plug in negative values into the fun house, which are absolute values, if you plug in a negative, if you go into a fun house with negative, you will come out feeling positive because you just went in the fun house. Same with absolute value. Even if you go in negative, you're coming out positive. You have a fun house though. If you go in positive, you're still going to come out positive because it's a fun house. So if you take the absolute value of a positive, it's still positive. Okay, let me write that down. So the absolute value of a negative is positive, but the absolute value of a positive, for example, positive 5, is positive. Okay, it always outputs a positive. Now, here's the thing. Let me show you Desmos. Desmos is a great tool, and here's what I've set up. Y equals, if you look on the top left, I can't draw on this, so you're just going to have to follow my words as carefully as you can. Y equals absolute value of x plus a plus b. These are sliders. For a, this adjusts the value of a, and this adjusts the value of b. Okay? Now here's the thing. We're going to adjust the b first. This is outside the absolute value. And we're just going to play. We're going to adjust the b first, which is outside the absolute value. If b is positive, what happened to the graph? Did you see? This is if a and b are 0, so you just have the basic y equals absolute value of x, because a and b are 0. Pretend they're not there. Y equals absolute value of x. It's a perfect v, slope of 1, with its vertex at the origin. But if b is positive, it moves up. If b is positive, it moves up. Play around. If b is negative, it simply moves down. There's an explanation for this, and I'll get into it, but that's all you need to know. It moves down however many units the b is. So look at the graph. Its y-intercept is -7, and look at the b value. It is -7. Okay? The amount of units it goes up or down is equivalent to b. There's nothing funny going on there. Okay? You don't need to double it or half it or anything. If b is 1, it's simply 1 up. If b is 4, it's simply 4 units up. Okay, so that's what b does. That's the b is on the outside of the absolute value. Now, what does a do? Let's try. If it's positive, it goes up, and if b is negative, it goes down. That's intuitive. What if a is positive? We might think, oh, positive values are to the right. And if a is negative, we go to the left. Let's test that hypothesis. If a is positive, will it go right? If a is negative, will it go left? Let's see. If a is positive, will it go to the right? Where is the v shifting? It shifted to the left. There is a reason for that. I will go into it. But just know, if this equation is y equals absolute value of x plus 2, it is opposite. If the numbers are inside the absolute value, the effect is opposite. It goes to the left. Now, if this equation happens to be y equals absolute value of x minus 4 plus a -4, that's -4. Y equals absolute value of x minus 4. Look at the graph. It's gone to the right. Anything inside is going to be opposite. Okay? I encourage you to go to desmos.com. Desmos.com. I will spell it out for you. Oh, wait, I don't want to do that. Desmos.com. And play around. Set it up just like I did. Desmos.com. Or graph all of these to convince yourself that this is how absolute value works. Okay? So let's graph this. Y equals absolute value of x plus 2. If you've learned the lesson from that, if it's plus 2 on the outside, it simply goes 2 units to the up direction. 2 units up. 1, 2. And we're looking at this V pattern. And we're looking at this V pattern. Okay. Bang. Okay, and draw arrows indicating it goes on forever. How do we double check that? Well, let's practice. If x is 0, y is 2. Okay, if you plug in a 0, the y is 2. Ah, that is why it moves it 2 units up, and that corresponds to that point, the vertex. If we put in a 1, y is 3. If we also put in -1, because the absolute value of -1 is 1, we get a y value of 3. This is why the V pattern arises. If you put in a 1, 3, that's 1, 3, that's here. You put in -1, 3, that would be here. If you plug in a 2, you get a 4. Yep, we see that here. 2, 1, 2, 3, 4. And if you plug in -2, you're still going to get 4, because the absolute value of -2, the absolute value of -2 is 2. 2 plus 2 is 4. Okay, and that point would be over here. That moves it 2 units up. So we should know how to graph this, and we should know how to graph that. Check Desmos if you are unsure. Now, left and right are a slightly different story, so let's practice on this. Y equals absolute value of x plus 2. I told you there's an explanation. We know this is moving left and right because it is inside, the adjustment is inside the absolute value. So if you're ever unsure whether it's gone left or right, you just simply plug in some points. 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. All right. It's 5, -5, 5, -5. All right. So plug in some points. The easiest point is going to be, let's go with 0. 0, if you plug in a 0 for x, you'll get a y value of 2. That's not really what we want, though. What we really want is to see where we plug in a -1, we will get -1. All right, that's -1. -1 plus 2, that's +1. Absolute value of +1 is 1. And here's the key. When x is -2, the y value is 0. You need x to be -2 in order to have a y value of 0. Okay? Focus in on what I just said. You need x to be a -2 to have a y value of 0. If you plug in a -3, we've got -3 plus 2, that's -1. Absolute value of that is 1. And we're starting to see the symmetry arise. -4, that's going to be -4 plus 2, that's -2. Absolute value of that is 2. Absolute value of -2 is 2. So let's graph all these. Well, here's 0, 2. Here's -1, 1. Here's -2, 0. Bang. That is the vertex, okay, of the absolute value. If I can go -3, 1 and -4, 2. That is why when you have a plus on the inside of the absolute value, it shifts it left. Why? Because the x needs to be a negative to zero out the y value, to have a y value of 0. The x needs to be negative to have a y value of 0. Or you just memorize its opposite. This is just left 2. Let me graph you another one. If you have x minus 3, you might think, oh, that moves it 3 units to the left. No, it does not. It's opposite when it's inside. This will guarantee move it 3 units to the right. How can I prove that to you quite quickly? Okay, this is right there. I can prove that to you quite quickly. Why? The x value, you see that x value? It needs to be 3. When the x value is 3, when the x value is 3, the y value is 0. And that's how we know it's moved 3 units to the right. To the right. It is the opposite of this guy. Oh, a little too big. It's the opposite of this guy. Okay, 3 units. That's -3, so we need to go 3 units to the right. Okay. Guys, the quizzes, you're on your own. Those are worth points. This review is worth points. So good luck. Try your very best. Ask me any questions you have and rewatch the video as many times as you need. Okay, mahalo.